Now let's resume the coding for this problem. So we have declared these variables. So then starting from 0, the first thing I want to find is the next one, right? When the next one appears. So I can use the function next true that I have defined earlier. I will be starting from 0. Yeah. So and then after I get this value, then there will be two cases. One of them is there's actually no ones. So the value that I have found is actually equals n. So then in this case we can sit anywhere. So then actually this I really just need to print out all the seat numbers. So I equals n, I plus plus. This is okay. And then we just print out I, print out the space. Okay. And after we do done that, we can just return. Okay. So then at this point, then we have find some ones. So for example, in this case, we'll find I equals 2. So then what we know is 0 and 1 are 0, are empty. So of course, when we have a chunk of empty seat in the beginning, we should the seat that maximize distance is the first one. But if this one appear either here or here, then if the index value is either 0 or 1, we actually haven't find anything new. So we don't really need to do anything. So so this we will check if it's greater than or equal to 2, then we actually have a find a available a possible seat, and the distance of that seat is indice minus 1, right? So because if we sit in 0, if we have a seat at 2 to be occupied, then there's only one seat in between, so should be ind minus 1. And we also need to remember this is actually a seat that that we can use. So we want to add this 0 seat to the answer. So for this we use this function called the pushback on vectors. So this is pushback means we add something in the back, and it's called push because there's a common data structure widely used, very important data structure in programming called stack. So the stack, people often talk about push and pop. So here the push essentially means add, and back means from the back. So we add something to the back, not to the beginning. Actually, let's put them on a single line. Okay. So at this point, the indices point to the first ones. So then we actually need to loop, so that we need to find the next 0. And then do something. Then we'll be dealing with sort of this segment of 0 in the middle. So we'll be writing a loop of keep skipping the block of 1 and then deal with the next block of 0. So I could write a while true here. And then I will break if I need. But in general, when this index is variable is greater than or equal to n. In fact, it shouldn't never be greater than n. When it's equal to n, I should break. So this is pretty safe, and we'll return to this and to see whether this is what we want. So at this point, we have a chunk of 1. So yeah, so here there's a choice of whether to whether to do something in the beginning of the loop or outside the loop. So let's do it outside the loop, because at this point, IND point to the first one. So here it will point to here. I really want to start with the 0. So I want to find the next the next 0. So this will be the next false, and then I will pass in this IND value. So what I want to do is to find out, starting from here, what's the next position of the next 0. So then if it doesn't exist, then we're done. So we'll just print the result. So then to do this, I need the next false function. So again, I actually could, instead of using next true or next false, I can use the next value. So actually, let's do that. Boolean value. So then here I just, okay, so this will find the next appearance of the value in this array. So then I can use it to find the next true or next false by, instead of doing here next true, I will just do true. And instead of doing this, I would do false. Okay, so this will find the index of next, the first, let me change the comment so that appearance of value. Okay, so right at this point, in the points to a 0, right? Points to 0, to the sort of it will point to here. So what we want to do is I want to find out when is the next one. So how long is this chunk of 0? So I will be moving this int forward as I go, but I need to remember where that this 0 starts. So I need a new variable start assigned to, and then I will find the next one. So now I will be looking for true. Okay. So then then again, there will be two cases. Either this is this int is beyond the end, or it's still within. So that means there actually is a 1. So these two cases need to be handled differently, because the last chunk of 0, we need to handle that differently, because that gives the optimal position in the end. If the chunk of 0 in between, I need to pick in the middle. So then there are two cases. Let's do the kind of on Euro case first. So then this means we are at the end. So then at this point, we just need to check whether this end give us a better position. So then the distance we can achieve is determined by n and start. So let's actually change this last to 0 just so that we can think about that. So suppose we move to here, then this start will point to here. So this will be 17 out of 20, I guess, 17, 18, 19, and then n will be point to 20. So if we take the here, so the difference is 3, but if we take here, there will be 2 0 in between. So the distance we can achieve is actually n minus start minus 1. So this is the distance we can achieve by sitting at the end. Now the question is whether this is better. If the distance is better than max d, then we need to use this distance, right? So we find a new better distance. So max d will be this, and then all the answers we have remembered earlier are no longer needed, because those can only achieve the old maximum distance. Now I find a new better distance, so I should clear out. So this clear basically just delete everything in this vector, because those are no longer needed. Of course, then we need to we also need to add this we need to do a pushback. Oops. Yeah, so that gives the too many information. So we need to push back the last seed, which is n-1. So, but then we also need to consider the case that these, when it's equal, I still need to do this pushback, because that maybe the last seed is no strictly better, but it's equivalent to the previous seeds. So in this case, I'm repeating this this code. Oh yeah, actually need to be this. Yeah. So my preference is to do it slightly differently. Again, this is really minor, but it's I guess this is kind of obsessed syndrome. So this is what the way I prefer to do. It's equivalent to the commented out version. So I actually don't add here, and then I always check whether the distance equals max d afterwards. So this is not in the else branch, and when it is, then we will push back this. So if its distance is greater than max d, then after this max d will equal to distance. So then by checking this condition, then I will push back. Otherwise, if distance is not greater than max d, if it's equal, then this also will push back. So this will be equivalent to the above, but it's just that this code appear once instead of twice. But in some sense, logically, this kind of anyway, I think both are pretty okay. But it's like I said, this is really quite obsessed doing this. Okay, and at this point, actually, I think it should be we can break out the loop here, because we are obviously done. Also, this is probably not strictly necessary, but it anyway. Let's break out the loop. Okay. So then the other case is the index is. The other case is that index points to next one, right? So now we have a chunk of zeros. We need to figure out what is the optimal distance we can achieve. So again, let's refer to these examples. So suppose we are here. Okay, so then start will point to here, and then end the indices will point to here. So the difference of them will be exactly the number of zeros in between this, I believe. So yeah, 1, 2, 3, 4, 5, 6. Yes. So there'll be, so the number of zeros will be in subtract start. Now this is the number of zero in between them. Then if we sit someone there, then what would be the distance? So we will take one seat out of all the zeros. We need to subtract 1 and then divide by 2. So here, if I have 6, I take 1, it becomes 5, and subdivided by 2, it becomes 2. So then it's this position and this position. So this is the distance, the maximum distance we can achieve by sitting by using this chunk of consecutive zero. So then the logic will be similar to what we have above. If this distance is bigger, then we will need to do this. And then there are two possible choices, right? So then one possible choice is there may be one or two possible choice depending on whether we have a odd or even number of zero here. So here we have two choices. If it's even, then we have if we even have two choices. If it's odd, we have one choice. So again, so we will use this. If this distance, then we need to add a new choice is to sit. This will be start plus distance plus 1. Yeah, here, if start is here, plus distance will plus 2. No, actually, should just be start plus distance. Well, could be wrong, but appears that's yeah. So the start will point to here, and if we add 2, we go here. So this will be one of the seat. Now the question is whether there is the other seat. Whether this is there are different way to do it, I guess. So I guess one way to do it is just to check if this is even. If the number of empty space is even. So we use this mod 2 to check whether they're even. Then we have we know we have a okay, this should be in here, because we do this only when the distance is actually current best. Okay, yeah, so didn't finish this. So now we will have a start plus the distance plus 1. Okay. Okay, so if the best achievable distance is the current max, so again, if this actually is the new max, this will happen. Then if it's the old max, then we still, if the distance equal the old max, this should be max d. We will first add the one seat we know will work, and when it's even, we know there's the other seat, the seat that directly after this will also work. Okay, so then after this, we have point to, yeah, so now we have find the next now this int will point to the int will point to 1, right? So now to restart this loop, we will want to find the next 0. So we will do this int equals yeah, so then at this point, yeah, so at this point, int will point to the beginning of the next block of 0, and if that's empty, then we will get out. Okay, so now after we are out of loop, all we need is just printing it out, but based on the condition. So the first thing we need to check is whether we actually find any meaningful solution. If there is if we didn't find any meaningful solution, we'll print whatever the thing that they asked us to print, which is what I'm watching the lecture online. So other than otherwise, we will print out all the things in the answer. So here I'm going to use another syntax, a different loop syntax. This will loop over all element in this collection. So a vector is a collection. So this syntax tells just give me everything in answer one by one, assign them to X. Okay, I think that's done. So let's see whether this works. Okay, so we got the compile error, no matching function for int bool. Okay, we call it next value, and I call it next. So I'm using next. So let's just change this next value to next. Let's run again. Okay, overload okay, yeah, so this yeah, okay, I forgot the D here. This line 52 and 59, I missed a typo. I need a semicolon, and here should be D. Okay, let's see. Okay, it's all wrong. Okay, so great. So now we'll be debugging the code. So okay, so typically when debug code, want to figure out sort of where the program is executing. So so let's do it. Okay, so let's see. Hopefully this environment will give me all the outputs. Okay, start from 7, indices is 8. That is the first one for the input, so that's okay. So looks like it's this next thing is wrong. So let's just be sure. What's the first next returned? First index is 1. So let's copy this this input to here to this comment. So, okay, so the first, yeah, so it's pointing to here. That's great. No, first this shouldn't be 1. We are trying to find the first true. That should be 0. Zero true. Yeah, that was a bug. Because we're trying to find the first appearance of that. So here the condition to keep going is when it's not, we keep increment. So that's the, yeah. But yeah, I hope to kind of to illustrate this. The bug was not intentional, so I did just made a bug. But I do hope to have bugs to illustrate sort of basic idea of debugging. Okay, so now it's actually correct. It's just that we have all this extra input, actual output, so it's incorrect. But everything else seems to be correct. So this what we are outputting last line is matches what they want. Okay, so we just need to get rid of all the debugging code. Okay, so run it again. Okay, let's submit. Okay, great. So